Okay, so I know at the end of the last video I talked about doing problems in this video. However, I've thought about it and I think I need to take you through a couple more concepts. Now this video is going to be sort of deep, so take it slowly. I'm going to go over some concepts, but what I'm trying to do in this video is to give you some general overall constructs, some templates for you to think about when a problem is being asked, when a problem is being stated, when you get on a test and you look at code, to be able to, at least from a general level, to break down the problem into what it's actually, or break down the code into actually what's being done, or to break down a problem into its component parts. And so what I'm going to talk about this time is how you actually target different pixels in an image. And what I'm going to talk about in general, and I'm going to type it here, is you are either selecting, in most of your problems, you're selecting all of the pixels in an image, or you're selecting your pixels by the color, and it could be either the exact color or the distance that the color is from something, from another color. And so that's where we got into targets and thresholds. So you could either, once again, select all pixels, or a problem is selecting a pixel based on its color, whether that be its exact color or giving you the distance away from another color, the color distance. Or you could select, we're selecting, let me spell that, we're selecting a pixel by its location. And by location, it could be its exact location, you know, its exact XY coordinate. It could be a location range, which means everything in the first half of the picture, or everything in the upper left corner of the picture, or every other column, or every other row. But those are all talking about different ranges of the picture. So you're not choosing every pixel, you're choosing pixels based on their XY location. Or you could choose the picture, excuse me, a pixel based on its distance from something. So like when we did the one with the big red circle in the middle, it was everything a certain distance away from the big red, the center of the circle got turned red. And so, but the idea, what I want you to really get here, is most of these problems are about selecting a pixel based on, we look at all the pixels in an image, we look at the pixels of a particular color or a particular distance, color distance, or we look at the pixel's location, whether it be exact or in a certain region of the image, which I put here as range, or the distance of that pixel from another pixel. Or you can do some kind of combination. So, you know, this is when the problems get really interesting. When you select a pixel based on color and location. Okay, so the trick here really is to, for this test, but particularly I think helping over the remainder of the course, is sort of to begin to look at problems in this context, and for you to begin to feel comfortable with navigating these kinds of things. And it's just going to take work and practice, which I'm going to try to do here. So when I look at the problems that you've been assigned, they break down into selecting the appropriate pixels, and then after you select the pixels, you have to apply the appropriate effect, whether it be doing a negative, or doing a grayscale, or moving something, or creating a new image that combines things, or changing or merging colors. So, but we'll get into those things a little bit later. What I want to talk about in this particular video are these different categories of how do you select a pixel. So this is going to take some time, so feel free to stop the video at any point in time and to get the concepts. And when you sort of have the concepts, then the next video we're going to work on targeting different pixels in an image based on their either color or location, and making those changes. Now, the good thing is we've already done some of this. So let me get rid of this. We've already done some of this. So I'm going to copy paste this here, or maybe not. Maybe I'll type it in. So going slowly might help here. Okay, so selecting all pixels in image. We've seen this before. So I'm going to define a function. In fact, let me copy paste this in the interest of time. I'm going to define a function here. So here I've defined a function, and it's got a very long name, but I tried to be descriptive in the name. So defining a function called select all using get pixels. So I'm selecting all pixels using get pixels, and we've seen this before. We saw this in the last video. I just set up this loop for pix in get pixels pick, and this one's going to print out all the pixels. And when you print a pixel, it just prints the color. And so I'm going to save this and then load it, and then type out this long name, select all using get pixels. There you go. And then we're going to go here, make picture, and once again give it, because this takes in a pic, the file name png. Okay. And when I do that, you can see, and we're still using this image over here, still using this image, and you can see that it gives me all the pixels. It gives me the red one, which is 25500, and we've talked about this, the green, the blue. So check through these RGB codes and feel comfortable with the fact that it's giving me all the pixels. Now, just a quick note, the file I sent you, I think in the gray box down here, the gray pixel, it's not a box, it's a pixel, the gray pixel down here, I think the value was 153 for each one. This file is a little different, and it's 128, but you still get the same idea. Okay, so anyhow, you could stop this, type this, run it, or you could just keep going here. But this is using the get pixels method, how you get to all pixels. All right, now I'm going to show you the same thing, but using the XY, the nested for loops. So, oops. Put a space between those. Okay, so this is the same thing using nested for loops. Okay, so so now you're in the video here. Okay, I'm going to get back with you, and I'm going to complete this video and then get back with you on this. So just a second. All right, so whoops. Okay. Like I said, I'll get back with you when I finish this in about 5 minutes. So anyhow, I'm going to select all, but this time I'm using the XY. So this is the same thing. These two pieces of code do the same thing. They may traverse the pixels in a different order, because once again we said this is going column, it's going down the columns, where this one's going across the rows. However, it's doing the same thing. So if I save this and then load it, and then all using nested XY, and then put make picture 3 by 3 PNG. If you notice, once again, if you look at this, you notice that this is the red one, this is the cyan one, this is the white one. So this one, excuse me, this is the yellow one. So it's red, oops, red, yellow, yellow, and then the white one. And so this one's going down each column. But nevertheless, we're getting to all the pixels. By the way, if you don't recognize these colors here, you really need to work on understanding at least these basic colors, these 9 basic colors here. This is why I chose them, what the RGB codes are for, what the red, green, blue channel values are for red, green, blue, yellow, cyan, magenta, white, gray, and black. Okay, so All right, so what we've done is we've gotten every pixel in an image. So if we want to get every pixel in an image, these are the two ways that we do it. Okay. All right, so we've seen that already. So now let's talk about selecting a pixel by color. So instead of looking through every pixel, we're not going to use every pixel. We're just going to choose the ones of a certain color. And actually, we did this in the first or second video, when you had problems like this. When I ask you, this is when I ask you to do problems like this one. Write a function called change green that will change the green pixel to gray. So it was targeting the green pixel by its color and going to change it to gray. Okay. Whoops, lost it all together. There you go. So you've seen this already, and so as you recall, when you're targeting a color, you're still going to go through every pixel. You just are going to only choose the one of a specific color. So that's when this if statement comes in. So if you look at this, and this is doing it with the 4 in get pixels right here. So if you look at this one, it looks very similar to this one up here. However, it has an additional if statement that I'm not going to use every pixel. I'm not going to print out. In this case, I'm printing. I'm not going to print out every pixel. I'm only going to print the ones out who have a color of cyan. All right. So if I save this and then load it, let me use the up arrow so I don't have to type this all out again. Let's see. Select by exact color. Oh, didn't work. Must have missed on the name. Select by exact color. Oh, using. I forgot the word using. Sorry. All right. So if you do that, you see the only pixel that now gets printed is the one that's cyan, which is 0, 255, 255. So there we go. So we're selecting that. Now, usually in the problems, you're not printing out the pixel, you're actually doing something to it. But we'll talk about the doing something to it in a later video. Now I'm just talking about how do you select the pixels, how do you get to the pixels that you actually want to change in an image. And so this is one way to do it. You can also do it by using the XY method, of course. So I'm showing you two ways to do each one of these. So now I'm selecting by exact colors using the nested XY. Same thing here, except for if you notice in the nested XY, I've got to actually, once I get the X and the Y, I have to now get a pixel. I have to get the pixel from the picture at this XY location. Remember, get pixel is different than get pixels with the S on the end here. Get pixels gets all the pixels in an image, and you use it in this for loop. Get pixel without the S gets a particular one pixel from an image at the XY location that you indicate. So here I'm using the X and Y locations from the loop, which we've seen loop through every pixel in the image. We're using those XY locations here to get the pixel, and then and we did that also up here. I didn't explain it up here, but we did do it up here. We get the pixel, and then now we're making a selection. If the color is cyan, then print the pixel out. All right. So I need you, if you're having problems with this, stop the video, work through these, type them in, and work through them. And of course, you don't have to use as long of a file name, but work through them until you get an understanding of what's going on with each line of code. And this is going to help you not only create programs, but it's going to help you also learn what's going on in a piece of code, in a function, in a program that they have written on a test. Okay? All right, so next up, we're going to get a pixel by its distance from another color. Okay? and we've seen this a good bit lately in some of the code we've been writing. So same thing. If you look, also notice what repeats and what also is different about these functions as opposed to the ones we've done up here. I have now, I'm going to go through every pixel. That's what these two lines do. I'm going to get each pixel. I'm going to get the color of each pixel. Then I'm going to check the color. I'm going to see, is the color of the pixel, the pix color here. This function distance tells me how far a color is from another color. So how far two colors are apart. So this is the pixel from the image. This is white. So I'm seeing how far the pixel is from the color white. And if that distance is less than 150, then print that pixel out. So it's going to go through this image and it's going to find all the pixels that have a color distance less than 150 from white, and it's going to print those out. And I actually don't know what those colors are because color calculations are interesting. That's why you do this here. But it gives you an idea. Like I told you, pink is closer to red than black is. In this case, pink would be closer to white than red is because it's a lighter color. So lighter colors are closer to white, darker colors are closer to black, so on and so forth. But this is about the distance the color is. So it's going to go to each pixel and calculate its distance from 150, and if that distance is, calculate its distance from white, and if that distance is less than 150, then it's going to print it out. I'm actually going to run this so you get a feel for how this is. And before I run it though, this function here, the second one does the same thing, but it does it with the XY. Now here I got to get the pixel because I have the X and Y coordinates. Then I've got to get the color from the pixel, which get color is going to get the color from the pixel. And then I do the same thing here that I did up in this function up here, is I take the color of the pixel, find its distance from white, and see if it's less than 150, and if it is, I print the pixel out. So I'm interested to see how this works. So let's do this here. Let's go, let's see, select by color distance using get pixels. All right, so save that, load it. Oops, I did that all wrong. Run it, and it says here, I find that interesting, the color using get pixels. I did the wrong one, I'm sorry. Okay, hold up. Not choosing the right function. Okay, select by color distance using get pixels. That's what I want to do. All right, so the only pixel that is within 150 distance of white is the white pixel, because this is 255, 255, 255, so that's the white pixel. If I change the threshold here, let's make it bigger, let's say 250. Let's see how many of these are within 250 of white. Alright, so I take that, load it. Now it says that gray and white are within 250. So by changing this threshold, I increase the number of pixels that are actually eligible to be selected. Let's go to 350. Let's see. And so all of these colors are within 350 of white. So that's sort of the nature of this whole threshold thing. By changing the threshold, you'll change the number of colors that actually fall within that distance. All right. But what I want you to do is notice how both of these two pieces of code here do the same thing. Understand each line and notice how they do the same thing. All right, next up is by location. So I'm going to copy and paste these in here. As I said, stop the video at any time. The beauty of videos is you can stop them at any time, go back, and understand what's going on. So here I'm choosing a pixel by location. Now, this style, the for in get pixels style, changes a little bit because keep in mind, for all the ones we've done up before, if you go back up here, we've gone before, we've never needed to use the location. Here, we've actually now got to get the x coordinate and the y coordinate of the pixel. And so what I did here is create a variable called pixx, excuse me, and pixy. And pixx is going to hold the x coordinate of the pixel, and pixy is going to hold the y coordinate. Okay? And then now what I'm saying is, if pixx is less than 1, or let's not even do less than 1 here, let's do equal to 1, then print the pixel. Okay? So what it's going to do is it's going to get all the pixels in the image whose x value is equal to 1. And so it's going to get all of, is that right? Yeah, it's going to get all of the pixels in this middle column here. Once again, this second function does the same thing. Now it does the same thing, but keep in mind, we're already doing the x and y here. So now we get the pixel using the x and y, and then we just check the x value to see if it's equal to 1. All right? So both of those do the same thing. So I'm going to save and load, and then I'm going to do select by location using nested XY. And then I'm going to do make picture 3x3.png. All right. And if you noticed, once again, go back to your RGB colors here. Gives me the 3 pixels that are in this middle column here: green, cyan, and gray. Green, cyan, and gray. Yours may say 150. If you do this, it may say 153, 153, 153, but that's the same thing. Remember, the image got changed a bit. So if I wanted to get a specific pixel, let's say if I wanted to get the, let's go for the magenta pixel here, right? If I wanted to get that one, well, that's on x equals 0, 1, 2, y equals 0, 1. So I could do this. I could say if pixx equals, if the x value here, let me do it down here in this function. If the x value here equals 1, now there's a couple of ways I could do it. I could say it this way: if the x value equals 1, and then I could put another if the y value equals, well, I'm going for the magenta, so x equals 2, y equals 1. If those two are true, then print out x. So I save that, load it, and what it should do is it gave me the magenta, which is all red 255, all blue 255, green equals 0. I could do it that way, or I could also combine these two in one statement and say, and the spacing of the parentheses does not matter, but I like to group them, so I could put an and in here, and I could say if x equals 2 and y equals 1, then print x. So that would do the same thing. I save that, load it, run it, and it gives me the same thing you see down here. So this is how you target them. Now, I'm not limited to equals here. Let's say if I say if I wanted all the pixels on the bottom row, right? Well, that's x is less than 3 or less than a width. So I could have put the width in here, but if x is less than 3 and y is equal to 2, because it's 0, 1, 2. So if x is less than 3, so it's going to give me x at 0, 1, 2, and y is equal to 2, so that's going to be this row. It should give me the white, the gray, and the black pixels. So I save that, loaded, right, and it gives me, as you can see, the white, the gray, and the black pixel. So you can do all kinds of funky things with this. Let's say if I wanted to cut the pixels based on this diagonal that goes, whoops, it's all wrong, that goes from red to cyan to black, that diagonal. Well, all the pixels above the diagonal, it just so happens that x is greater than y. So for these 3 pixels here, the green one, the blue one, and the magenta, all those, the x value is greater than the y value. So let's say if I say, I could come in here and say if x is greater than y, right? So if x is greater than y, then put the pixels out. So I should get the green, the blue, and the magenta. So that's these. Likewise, if I say if x is less than y, that's the yellow, the white, and the gray. So if x is less than y, then I should get the yellow, the white, and the gray. Okay? And if I said they were equal, then I'll get the red, the cyan, and the black, which are all, this is 0, 0, this is 1, 1, and this is 2, 2. So it will give me those 3. Save, load. So there they are there, red, cyan, and black. So all this exercise is to get you used to thinking through the programs, seeing what's there, understanding the RGB codes. One of the example test problems, they talk about doing things in the upper top of the image, upper half of the image, lower half, or above the diagonal, below the diagonal, and so that's why I covered this here. So take the time to understand how these 2 pieces of code are the same, what each line does, and also this how I'm targeting pixels by their location. Okay. The last but not least is you can also target pixels by not just their location, not just their color, but by both. And so that's what these are. So if you look here, I'm going through the pixels, right? I'm getting the color of each pixel, I'm getting the x and y coordinate of each pixel, and here I say if the pixel's x value is less than 1, and if the color is equal to yellow. Once again, I did these in 2 if statements. I could have just as easily put an and statement here, right? So this could look like this. So this could look like this. And once again, I'm just removing the spaces from the parentheses to make it easier to read. But so if you feel comfortable with the and statement, then do it this way, because what this says is if the x value of the pixel is less than 1, which means it's in the first column, and the color is yellow, then print the pic. So it should just print the yellow pic here. This one, let me change this so it does the same thing. This one, I go to the x and y, I get the pixel so I can get its color. I already have its x and y value from the loop variables here. So if x is less than 1 and pix color is equal to yellow, right, then print it. So both of these codes do the same. So this whole thing about location and color, this is how we select pixels. We either get all the pixels, we get the pixels by color, whether it be the exact color or color distance, and then we can get the pixel by its location, whether it be its exact XY location or the column of values that it sits in or a range of values that it sits in. The lower left hand corner, the upper half, the lower half, all of that. So those are all the ways that we select images in our code. So when I look at a question or problem, I'm looking for, okay, how do we select the right pixels that we need? I'm sorry, this is how we select all the right pixels in our code. How do we select the right pixels that we need? That's the first piece. The second piece is, what effects do we have on them? How do we change them? Do we change them all purple? Do we change them to their negative? Do we change them all grayscale? What do we actually do? That's another discussion, but right now what I'm talking about is how do you actually get to the pixels. So look at this, work with it, understand it's going to take some time. I'm going to try to give you some problems in the next video so you can work on this, and then the videos that follow that will be talking about how do you do different effects like negative and grayscale and that kind of thing. So now I have to answer your text, so I will talk to you later. Bye.